As we know, a harmonic series diverges to infinity. But if we just get rid of all the numbers that contain 9s, then it'll converge. Right? So any digit that contains 9, get rid of all of that. So the reason is because we can first focus on the denominator. Right? We can look at such numbers starting from 0, 1, 2, all the way perhaps to 10 to the power of m minus 1. Right? So this number is basically 99999. We got m many of 9s in here, such as 10 to the power of 3 minus 1, that's 999. Right, so out of these many numbers, I want to know how many numbers are there that don't contain 9s. Right, so meaning if I take any number out in here, I can look at its every digit. Right, first digit, second digit, and many digits. Right? So out of so many blanks, first blank we can fill is that we can fill 0, 1, 2, 3, or all the way up to 8. Right? Out of so many different options, right? We have exactly 9 different options. Right? Exactly 9. Because we cannot have 9 here. So I got 9 different options for first digit. Right? Also 9 different options all the way up to the last digit. So any number out of these numbers, right? It has so many different possibilities with multiplication rule. Right? We have 9 times 9 times 9, so many different combinations. How many different combinations? Right? We have exactly 9 to the power of m, this many different permutations or combinations, right? So meaning, how many numbers are there out of these numbers? Right? How many numbers that don't contain 9s? Right? I have exactly 9 to the power of m numbers, right, out of here that don't contain 9s. So if I just, because remember, we cannot have 0 on the denominator, right? So right now I can just have a look at 1, 2, 3, all the way up to 10 to the power of m minus 1, right? So how many numbers are there that don't contain 9s, right? I have exactly 9 to the power of m minus 1 numbers that don't contain 9s. Now, then I can just have a look at from 1, 2, 3, all the way up to 10 to the power of m minus 1 minus 1. Out of these many numbers, how many numbers that don't contain 9s? I have exactly 9 to the power of m minus 1 minus 1. Right? So then again, I want to have a look at the numbers starting from 10 to the power of m minus 1 minus 1. All the way keeps increasing all the way up to 10 to the power of m minus 1. Out of these many numbers, how many numbers that don't contain 9s? I have exactly 9 to the power of m minus 1 minus 9 to the power of m minus 1 minus 1. I have exactly 9 to the power of m minus 9 to the power of m minus 1. This many numbers, right, out of these numbers that don't contain 9s. So, for example, from 1 plus half plus all the way up to, because remember, I cannot have 1 over 9, right? Only up to 1 over 8. So how many numbers out of these numbers that don't contain 9s? I have exactly 9 to the power of 1 minus 9 to the power of 0. Right? This many numbers that don't contain 9s. Of course, cannot have 1 over 9. I must start from 1 over 10. plus all the way up to, remember, I cannot have 1 over 89 or 90 or 91, right? So it's only up to 1 over 88. So out of these numbers, how many numbers that don't contain 9s? Like I said, 9 to the power of 2 minus 9. Right? This is exactly how many numbers that don't contain 9s out here. Again, so next I should start from 1 over 100, right? There's no more 99, 98, 98, 97, so it's only this. Then also there's no 1 over 109, 119, 129. So also there's no, so there's only up to 1 over 888, because there's no 889, 890, 800, no such thing, right? So, like I said, how many is it from, right, if m equals 3, right, from 300 minus 1, 99, 99 up to 999. 90, but there is no 99, so it's okay for me to start from here, right? It's the same as if I start from 1 over 99, so up to 100, 1 over 100, 999, but there's no such number. So this is equivalent, right? Equivalent to say from 99 up to 999, right? This many numbers that don't contain 9s, that's 9 to the power of 3 minus 9 squared. Right? So eventually I can just loosen the inequality a little bit. I can just replace every fraction with 1, make it a little bit bigger, right? So 1 plus 1, how many 1s? 9 minus 1 ones. Replace every fraction here with 1 over 10, right? Make it a little bit bigger. 1 over 10 plus 1 over 10 plus 1 over 10. How many 1 over 10s? 9 squared minus 1 minus 9. Also I have replace every fraction with 100, 1 over 100. So 1 over 100, 1 over 100 plus 1 over 100. How many? Exactly 9 to the power of 3 minus 9 squared. Right? And so I've just loosened this infinite sum, right? Loosen every fraction, first replaced with the bigger fraction, right? Replaced with the bigger fraction. Now the pattern is clear. I have exactly, so 8 plus common with the, right, so many 1 over 10s, right? So 1 over 10 times 9 squared minus 9 plus I have so many 1 over 100, right? 9 cubed minus 9 squared, and so on and so forth. All right, that is 8 plus. Can factor out 9. Factor out 9, and I'm left with 9 minus 1. Right? Again, factor out 9 squared. I'm left with also 9 minus 1. So on and so forth. Right, that is just, right, every time I can just have 9 minus 1, 8. Right? 8 times 1 over 10 times 9. Again, there's 8. Right? 8 times 9 squared over 100. Right? So again, factor out 8. 8. I'm left with 1 plus 9 over 10 plus That is 9 over 10 quantity squared plus all the way. So this is a geometric series. Right? Common ratio, 9 over 10. Right? 1 minus common ratio. First term 1. Right? Infinite series, infinite geometric series. And that is just 8 times 1 over 10. That is 80. Right? So we have a positive series. Positive series loosened a little bit, right? After loosening it, it is bounded above by 80. Right? This positive series has to be convergent after we get rid of the numbers that contain 9s.